Okay, let's dive right into this. We're going to unpack the architectural patterns for building with Amazon Bedrock. It's a super powerful service, but we really need a clear map to build robust, production-ready applications. So if you've looked at building with generative AI, you've probably felt this, right? There's this huge landscape of models, APIs, all these features. It can honestly feel like you're trying to navigate a maze without a map, and for any developer, that's just an overwhelming place to be. So to cut through all that complexity, we're going to use one simple but really powerful analogy for this entire explainer. Just think of Amazon Bedrock as a massive food court. Each restaurant is a different AI model, and all the services around it, well, they're there to help you get your meal efficiently and safely. This is our map.
All right, let's start with the question I get all the time. Which model should I use? In our food court, this is basically like asking, what should I eat? And you know what? There's no single best meal. The right choice depends completely on what you're in the mood for, or in our case, what your application actually needs to do.
To make a smart choice, we need a framework. So here are the 6 critical things you absolutely have to consider for any project. We're talking about speed, price, how smart it is, whether it can handle stuff like images, if it can use external tools, and of course, how much information it can remember at one time.
Now, what's really fascinating here is the trade-off. For something like a live chatbot, speed is everything. I mean, a slow response just kills the user experience. But for a nightly job summarizing sales data, you can totally wait a bit longer to get a much more detailed, much more accurate analysis. It's all about picking the right tool for the right job.
And how you pay for your model, that's a huge architectural decision. On demand is kind of like just walking up and ordering from the counter. It's perfect for unpredictable traffic. But if you know you have a consistently high volume of orders, you use provisioned throughput. This is like renting your own private, dedicated kitchen line. Yeah, you pay by the hour, but you get guaranteed predictable performance. No waiting.
So here's the key takeaway, especially for architects or anyone studying for a certification. When you hear phrases like guaranteed capacity, or avoid throttling, or production SLA, your mind should immediately jump to provisioned throughput. It's the enterprise-grade answer for predictable scale.
Okay, so you've picked your model. Now you have to actually write the code to use it. But what happens when some new, better model comes out next month? You definitely don't want to rewrite your entire application just to switch from one food stall to another, right?
And this right here is the core principle that AWS recommends. The whole goal is architectural flexibility. You want to build your application so that you can swap out the AI models underneath without causing this massive engineering headache.
So how does Bedrock solve this problem? With its Converse API. Think of it as the food court's universal ordering kiosk. You place your order using one standard format, and the kiosk figures out how to route it to the right kitchen. This means you can change which model you're using just by changing a config setting, not your code. It's a game changer.
And this just perfectly illustrates one of the best features for user experience, streaming. Instead of waiting for the model to generate its entire whole response, streaming gives you the answer token by token. For a chatbot, this is the difference between staring at a blank screen and actually seeing the reply type out in real time. It just feels dramatically faster.
So we have our model and we have our code. Now we need to get serious. We need to make this thing production ready. And in our food court analogy, this means we got to handle the lunchtime rush hour and make absolutely sure the food is safe to eat. This is a classic operational problem. Your app is a huge success, traffic spikes, and then all of a sudden, your API calls start failing. This is known as throttling, and if you don't have a plan for it, your application is going to fall over right when it's the most popular. So here's the standard architect's playbook. First, when a request fails, don't just hammer the API again. You need to retry intelligently, waiting a little bit longer each time. Second, you might need to slow down how many requests you're sending all at once. And finally, if this is a constant problem, that's a huge signal that you need to buy that dedicated capacity with provisioned throughput.
Now for the most important mindset shift when it comes to security in generative AI. You have to start with this fundamental assumption. You do not trust the model.
You don't trust it, you contain it. See, the goal isn't to hope the model behaves. The goal is to build a system of defenses around it so that even if it tries to do something harmful, it just can't. This is what proactive security looks like.
And that containment comes in layers. You check what goes in, and you check what comes out. You strictly limit what tools it can use, and right there in the middle, you have Bedrock guardrails. This is our food safety inspector, automatically checking for harmful content, denying sensitive topics, and filtering out personal information.
Okay, we have covered a lot of individual concepts. So let's put it all together with a complete real-world blueprint, a voice-powered AI receptionist for a medical clinic.
And this just shows how everything connects so perfectly. For the live call, we need low latency, so we use Converse Stream, our fries served one by one. For safety, we apply guardrails. That's our food inspector. To handle the peak lunchtime rush, we use provisioned throughput, renting that private kitchen line. And for auditing, we turn on logging, which is just like keeping all the receipts. It all maps back perfectly.
So if you take just one thing away from this explainer, please let it be this. Bedrock is not just a menu of AI models you can pick from. It is a complete, integrated, operational system with all the tools you need for scaling, safety, and reliability. It's the entire food court, not just the list of restaurants.
The patterns we've discussed today, from picking the right model to defense in depth, these are the fundamental building blocks for creating serious, scalable applications. You now have the map. You have the architectural playbook. So the only question left is, what are you going to build?